And we will talk about a couple of things that will be on the test, and then we'll start with stuff that is also important, but that is not in the course objectives, so I don't test you on it. I don't know what's the right rule, but that's how I do it. Now, a couple of things that we need to know. One of them is exceptions and exception handling. Let me close the door. Half close the door. Exceptions are a cool mechanism that is widely abused. What's the idea? Stuff happens, right? And sometimes you don't know how to deal with it because of abstraction. What should an application do when it cannot find a file? What do you think? If you're writing an application, right? You go find a file and you don't do it. You don't find it there. What should you do?
Turn a null file. Yeah, say there's no file there.
Well, if you're in a component, you should say there's no file there, but what should the application do? Well, depends on the application, right? Depends on the file. If it's something that I really need before I can start, then I will just croak, right? Have a horrible error on the screen and die. But maybe it's not an important file, and then I shouldn't die. I should use some default instead of that thing, right? And then how do I display stuff on the screen? Well, it depends. Do I have a screen? Am I a server application? If I'm a server application, then maybe I should write it to a file. Maybe I should send an email to somebody, right? Maybe I should put it on the screen. And which screen? If it's a GUI, then on the GUI. If it's a phone, then on the phone, right? So, who knows what to do? Definitely not the piece that is trying to read the file, right? Not the piece that is calling the operating system to open a file. Does that idea make sense? The low-level components don't know what to do, how to deal with the error at a high level. All they can do is say, there is an error. And then somebody at the high level in the application, somebody who calls somebody, who calls somebody, who calls somebody, who eventually tried to read the file, would know how to deal with it, right? Does that idea make sense? In object-oriented applications, people came up with this idea of structured exceptions, which are cool and horrible at the same time. Basically, what the application does is it throws an exception, right? And then, if I knew that there was an exception, I would write my code like this. I would try, and here I'll write the actual code, and then I'll try to catch that exception. And say, oh, catch this exception, and then I can put more code there, right? Oh, if it was this, then do this, that, or the other thing. And so this code can throw the exception wherever in the chain call of the chain call, right? The chain of call. So I call the method that calls a method that calls a method that calls a method that eventually throws an exception. This would still catch it. Yes?
How do you catch multiple exceptions?
Okay, you can catch more than one by putting more catches here. But it becomes interesting. Let's go play, right? Let's go play. Let's open this guy, create one more thing. Oops. Rename. Okay. Item event static. Void. It's a very useful thing. First of all, one cool thing. Let me. First of all, I am getting an error because Java is telling me, wait, that method throw is true said that it may throw an exception and you're not catching it, right? And so what the heck would you do if it throws an exception? One way of cheating for now is to add throws exception to main, and then Java will quietly go away, which is good for now. So what would happen if I run this? I get this beautiful thing, right? There's an exception, bad stuff happened, and it actually tells me, right, which lines of my code, and it shows me the full stack. That is cool, right? Does this make some sense? Just the mechanics. If I were to catch that exception, right? I need a try catch. So what happens if I now run this code? It would catch the exception and print for a wild exception back stuff. Probably should add spaces. Does this idea make sense? I could do, let's see. Let's do more stuff to show bigger. you have a recursive thing that's going to just call itself until eventually it throws an exception when it reaches 0. Right? So I can do it here. Let me do it before. And it shows me the full stack, right? Because I called it with 5, then it called it with 4, with 3, with 2, with 1, and eventually with 0. Does this idea make sense? What's the point of showing you this? It's an easy way to show you that, right? It may be 7 layers deep or whatever, right? Normally, it wouldn't be with recursion, it would be a function that calls another function that calls another function that eventually shows bad things, right? Is this cool or what? What are exceptions? It's just a class, right, called exception that has a bunch of subclasses, right? So actually, let's see. Illegal format exception, why not? There is an illegal argument exception, right? Or actually, let's do this. In here, I can do what happens if they call me with a negative number? I would get into an infinite loop, right? Or an infinite recursion. So let's check for it. So now what happens? My thing can throw more than one thing, right? What would happen if I run this right now? Almost the exact same thing, except that, no, actually the exact same thing, because it doesn't tell me which exception. Oh no, because I got Java-lang exception 0. Which is okay, right? So exactly the same thing. If I called it with -5, right? Then I would get something different. I would get a different kind of exception. I got an illegal argument exception. Does that idea make sense? And that's a very convoluted way of getting to Neil's question of how do you catch when it can be more than one thing, right? I could write try this thing Oh, I can actually just do this. They will print themselves the right way. Does this make sense? Now I have one try and two catches. So I'll catch either one of those two things, right? In this case, which one's going to get executed, hopefully? The first, this one, right? Woohoo! And then this is the, if I called it with something like 5, I would get this one, right? Let me delete this. So that is how you can catch different exceptions. Why do we need to learn about exceptions? Because you are becoming adults. And you should know that stuff happens. And the operating system will sometimes croak, right? If you are reading from a file, what could go wrong? You open the file, it's there, you start reading from it. Can you read one more byte from it? Maybe the hard drive is broken. Maybe somebody took the friggin' USB from the computer, right? Maybe somebody tripped over a network cable. Bad stuff happens to good programs. And so you need to kind of figure out how to deal with it. In Java, most of the time, the standard library will raise exceptions. The danger with exceptions is that sometimes you can use them as a control mechanism. It's almost like an if statement, right? And so if I return different things, right, this works almost like an if statement. That you shouldn't do because it's very confusing. You are going to get killed eventually by your own things. But you need to figure out how to catch exceptions when the libraries do it. Does that make sense?
So you have to know all the ways that they could break you?
You should. What many times end up doing is just doing this, catch exception E, and that just says whatever happened. I don't know anymore, right? Ideally, you should, and this is something that Uber sucks, but ideally you should know exactly all the things that could go wrong and come up with ways of dealing with it. What that really means is that when you have a program, right, the happy path is going to take you about 5% of the actual cost of the program, right? Because there is so many things that can go wrong. And so it takes you a lot longer to deal with all this stuff that can go wrong than to actually do the frigging thing that you were trying to do. Life sucks, yeah. That's why, and eventually, right, you cannot check all the things that can go wrong. You forget 5 or 10, which is why you end up with patches. But many times, just you need to figure out how to deal with all the exceptions, and that ends up being a lot more painful than trying to do what you were trying to do.
Does it stop? Does it push on the code?
It stops the execution here, and it goes to here, and then it keeps going.
It keeps going.
Keeps going after, yes.
That is following methods after that?
Yes. So unless you stop, actually, sorry, there is one more thing, which is finally. The finally code will get done regardless. Whether there is an exception or not, it will always be called after. And after any exception handling. And then you could have So in this case, right, this skips, this gets done, right? Other bad thing. Then the finally gets done with the try. And then it keeps going. Only one catch gets executed. And they get tried in the order that you define them. Because an illegal argument exception is also an exception.
And is it possible to write the exception in an error log file?
That depends. Did you catch the exception? You can do whatever you want with it.
Or is the exception automated write it in an error log?
No, that's you. There's no automated anything. You get to write whatever you want. They do have a couple of things. They have print stack trace, which will print the whole trace, and you can pass it a print writer. So you can pass it a system.out. So the facilities are there, but no, you have to do it.
Okay.
You have to do it, yeah. The typing system in Java will try to protect you from not catching exceptions, right? However, truly in a computer, almost anything can go wrong, right? And so they decided at some point in time that no, it was too cumbersome. So you can throw things that are not exceptions. And also they have a runtime exception, which is a particular class that you can throw and not declare here. So if this guy throwed a runtime exception, then it doesn't need to be declared. And I can actually eliminate this since I'm officially not throwing any exceptions. The default exception catcher, exception handler catches it and handles it. And the default, if you have an exception that's not caught, is to print everything and die, which seems fairly reasonable. Many times you can get away with saying throws exception here. You probably shouldn't, but if you have noticed, we have done it on the assignments, right? There are things that could go wrong, but we never catch them, and you just keep going. Any questions on exceptions and exception handling? We have covered all the things, I hope. You have a throwable interface, that's kind of the interface that corresponds to the exception class. You have the exception class, which is the most common one, and its subclasses, and runtime exception, which don't have to be caught. To throw an exception, you do throw, and then you do whatever you want to throw. Half the time it's a new exception and you pass whatever. To catch exceptions, you do try, you write the code that may generate an exception, and then you write catch, and whatever exception you're trying to catch, you may have more than one catch. You could have finally for stuff that it gets done. And if you need to declare in your class that you throw an exception, you do throws. And ideally, you should be as specific as possible. You shouldn't be saying throws exception. If you throw an illegal argument exception, you should be trying throws illegal argument exception. You can throw more than one thing and separate with commas. So throws this, this, and that. How to define your own exception class? Just extend exception. And that's it. It's just a class. no magic. And you could actually do really horrible things like no, it has to be a throwable. Okay, so it has to be a throwable. You cannot just throw an integer in Java. What you throw has to be a throwable thing. So there is one thing kind of above exception, which is throwable. Does that make sense? Cool. No questions? Going once, going twice. Cool. We'll talk about them again on Wednesday. So now we can talk about file I/O. Files are always a pain. We have this really cool thing that came from whatever, but it became kind of the Unix system, right? That's what popularized it. What is a file? It's an object, okay. What does it have? What can you do with a file?
Store information.
You can store information, so you can write to the file, and then what else can you do? Read to the file. Read from the file, right? What do you read and write? Bits. That makes sense, right? What's the lowest thing that we usually deal with? Yes, you write bits, but we group them into bytes, right? One character, 8 bits. We never do less than that for whatever reason. So you cannot have a file that contains 3 bits. You always have to have 8, 1 byte. Does that idea make sense? And that's it. As far as files are concerned in most operating systems now, all they contain is bytes, one after the other. There is nothing else you can do to them. Does that make sense? From there we build everything else, right? Given that you can read bytes, then you could read ints, right? As long as you decide how the heck do you represent them. Which bytes go first? Well, you need to define how big is an int. How big is an int? How big is an int in Java?
Usually 4 bytes.
Yes, an int in Java is 4 bytes. But like in other operating systems or languages, it may be something else, right? And so, which way do you write those bytes? That's big endian versus little endian, right? You could write them the least significant one or the most significant one first, and that would actually be different. But once you do that, then I can write ints, right? And if I want to write people, as long as I define how to put my class person, right, and represent it, and how to serialize it, and then how to read from it, then I can write person, right, or whatever I want. Does that idea make sense? The main abstraction is it's not saying that you can read bytes from or write bytes to. There is one more thing that you can do with some files, which is seek, move, right? So if you have a file on disk that's huge, I don't need to read every byte to get to the byte number 2,000,000,005. I can just move to the byte 2,000,000,005, that will skip a bunch of stuff and read or write from there. Does that idea make sense? Can I do that with all kinds of files? It depends on what a file is, right? If you're a sysadmin, hopefully not, but you may still deal with tapes, which are the ugliest piece of manure ever. But they used to be a lot cheaper than this. And so we use them. And tapes are sequential. You can never I mean, you need to physically move the tape. So normally you can't just stick within a tape. Just read it from beginning to end. So they were very useful for backwards. But if you're old enough to use a Commodore 16 or 64 with a tape, and you would listen for the sound when a program ended and another one started, you would stop, rewind a little bit and go from there. It could be worse. You could be dealing with perforated parts, which I never did. As a kid, I had a Commodore 16. Woohoo! Commodore 16? Yeah.
Number 16.
Yeah.
Oh, 64.
No, I wasn't rich enough for 64. I got a 16, which was still amazing. I mean, my parents had to do a sacrifice to get me a Commodore 16. But the 16 was the cheap version of the 64.
Yeah, in the US it's called the VIC-20.
No, the VIC-20 is a different one. Yes.
I've never heard of Commodore 16.
Maybe it wasn't. Yeah, it's a cheap version of the 64. The VIC-20, I don't remember if the VIC-20 is after or before the 64. After the 64, you got the Amiga, which people still use sometimes today for uncut. Who knows why, but.
Oh, hey, there's an auto shop in Russia that uses a Commodore 64 to underdiagnosed.
I mean, hey, they sort of kind of worked. They were actually amazing for the time. They were an obscene amount of fun. But you had to be, they were expensive and, well, they were obscenely cheap compared to real computers at the time, right? That's the cool thing. You didn't have even floppy disks. So you would type your program and if you didn't have a tape, it would die when you turned it off. Fun times, fun times. Walking up hills in the snow, uphill both ways, that kind of stuff. Anyway, God, file input and output. It's binary data, we are reading bits and bytes, we can seek for some of them, right? If you are reading from a tape or if you are reading from the network, you cannot see, right? Really cool thing about Unix is network is viewed as a file. You just open your connection and write stuff to it and read stuff from it. No biggie. It's not quite true, but it sort of kind of works, right? What do you think happens when you're trying to read from a file? Normally you get a byte, but what else could happen? Bad stuff, exceptions, right? Somebody took the USB out, somebody disconnected the network cable, and that file wasn't a file, it was a network socket, right? The other machine died, and you're trying to connect to it. The internet died. Bad stuff can happen, and so they will do exceptions. The abstraction of reading bytes one after the other is called a stream of bytes. And so one of the Java classes is called the input stream. One other thing, which is a standard problem with Java. Java was created around 95, right? So it's 21, older than some of you. Java is actually created like 91, so it may be older than some of you. Yeah, it's fair. It just has oodles of words, right? In Java, for backwards compatibility, they almost never delete the old words. They just put stuff on top. So the file I/O is horrible. And it's horrible 3 times over. So they come up with new stuff and they put it on top, and they come up with new stuff and they put it. Normally you just learn whichever one is useful at the time and that's it. But sometimes you need to go look at the ones below. A file input stream is an input stream that can read from a file. So you have an input stream, and an input stream is an abstract class, so it has some methods that are not implemented. It implements the closable interface, which gives you a close method. Maybe. Yay, close. And it has a few things. Has an available method that will tell you about how many bytes it thinks that it has available. It's not a promise, it's a guess. Has close. It has mark to be able to go back there. Mark supported tells you whether you can mark or not. Then it has read. They did horrible things. What should read read? A byte, right? What does it return? An int. Why? So it can return stuff that can return error conditions in the stuff that it read. You can also ask for it to read a bunch of bytes when you pass it an array. Reset goes back to mark, and skip just skips a bunch of bytes. Notice this idea of blocking, right? What happens if I try to read from a file? In terms of computer speed, right? The computer is going to have to, in the best of cases, go look at the hard drive, right? How are hard drives according to computers? They are insanely slow, right? Like obscenely slow. Your computer does billions of operations per second. That's gigahertz, right? That's millions. Do we do more? 1.2. Sorry? Are those giga or tera? Giga. So they have like 2 billion, right? You get like 1 or 2 billion operations per second, right? Hard drives, their seek time is usually measured in like milliseconds, right? So by the time you go read something, if everything is perfect, you can do 10, 20,000 things in your computer. So as far as computers are concerned, reading means I block, right? If you ask me for something, if I already have it in memory, I'll give it to you. If not, right, then I will block that operation. You are now in the queue, and I'll go do other stuff. I'll go run other programs. I'll go do whatever else, right? How long is that operation going to take? Who knows? If it's a hard drive, it may take a few milliseconds. If it's reading over the network, it may take however long it takes until that other idiot on the other side presses the key, right? And, or if I'm reading from the keyboard, it can take however long it takes a person to press a key, right? And for computers, we are insanely slow, right? It can take a few seconds. God. So they will block and stop executing you, go execute other programs, and eventually you will type something and they'll come do whatever. So that's the input stream class. The file input stream class reads from a file. And it has kind of the same thing, except that the constructor, it can either take a name for a file, or a file descriptor, or a file class which doesn't have the data. The file is the file metadata. Like this is what you get if you open a folder or something like that in Java. And then it will read from there.
So does it mean that a file class can accept any kind of file? Like an MP3?
Yes, yes,
A CSV?
yes. All those things are bunches of bytes. why would it care about the name? An MP3 is just a bunch of bytes, right? A CSV is just a bunch of bytes one after the other. It's your libraries that go on top of that that give it meaning.
So you can read it and you can put it on a variable, or we need to read it and write it?
I can read it byte by byte and then do whatever the heck I want with it.
So you can manipulate it.
I could write it, I could.
You put it in a data array, store it later.
Yeah, once you read it, right, then you can do whatever. So I can either read byte by byte or basically read the whole file if I want to. But that may be, it's a 5 gig file, so has more RAM than my full phone.
What I believe I have a hard time to understand is you are reading a byte, but I mean, you have a file that is a string, or if you're reading a doc file, like a word processor file, you have bytes. Oh, okay.
I have bytes, and then I can interpret them and decide, oh, the first few bytes is like if I'm reading a CSV, then I can say, oh, I need to go until it finds a new line, and so that first line is a header or not, depending on which, right? You usually need more, like, well, is that the header or not?
Okay.
And but they are just bytes one after the other.
Okay.
As far as the basic libraries, they are bytes one after the other, and then you build on top of them. There are ways to read. I tend to use always text files because binary files are horrible. I'm a Unix guy. We do text. It's a lot easier because you can also look at them as a person, and also because you can edit them with VI or Emacs or whatever. So if you can deal with text files, it makes your life much easier. Binary files tend to be a lot smaller if you can make them, so that's the trade-off. But so the input stream class is the one that we use for reading. A file input stream is an input stream that corresponds to an actual file on disk. And we can use the scanner class, which is what we have normally done. Because the input stream class doesn't have many useful stuff, I can only read bytes. I cannot read ints. Once I have a scanner based on there, then I can do other stuff like next line or next int or something like that, right? There used to be a buffered input stream. That's what we used to do before we had scanners. The buffered input stream has more or less useful methods. My output is a file output stream or a writer to write. There used to also be a reader class instead of the scanner class. And a reader is almost useful. But they weren't that useful, so we did scanner. So there is kind of 3 generations of reading technologies and 2 generations of writing. Isn't that terrible? One cool thing is that another one of the input stream classes and output stream classes uses a string. So you can actually use it have a string and say, hey, think that this is a file, and then you can go read it or do whatever, which is fairly useful for testing and other stuff. And that is kind of all you need to know about files and input-output, or all that is fit to print. All the other stuff you go learning and looking through those things and trying to do stuff. We are probably going to do some examples on Wednesday. But that is about it. Now, let me mention one more thing that I haven't even written stuff, but I think you really ought to do. You really ought to learn, which is unit testing. JUnit is one of the libraries when you are writing programs, right? Especially when you write functions that call other functions and things like that. How do you go about it? How do you imagine that I tell you that you need to write a max3 function, right? I've been giving you the unit test. Imagine that I tell you that you have to write a max3 function that is what would you do? Well, okay, maybe I remember public static, sorry, let me write my main before I okay, maybe what I want to do is to write a max2 function, right? And then use it, right? And then here I can just write return max2 of A1 and max2 of A2 and A3. Right? Maybe? And then I can test it. Right? I need to change this guy. And I get the wrong answer. Woohoo! What happened? Oh, what is wrong, right? Well, here's what really happened, right? We messed up by not testing first max2, right? Where is the error? Is it max3 calling max2 wrong, or is max2 the problem? It's max2 on purpose, right? They inverted this thing. Right? But how do you know? Oops. How do you know where the problem is, right? What you normally do is you write tests for max2, right? I shouldn't call max2 until I'm satisfied that it works, right?
Yes.
So I tend to do stuff like this. How many tests? Right? Right? So you go, you write a bunch of tests, right? You are happy, then what do? if I do this and then start using it, right, I lose a bunch of information, right? Also, I introduce the possibility of me coming and doing dumb things and never retesting. So later on I decide that I want to do greater than or equal, right? Does it passes all my tests? Maybe, maybe not. I don't know. I deleted all the tests, right? So now I need to test it again. That is a bad idea, right? So you should try to write your tests and keep them. These are called unit tests. There are several levels of testing. Unit tests are kind of in this terminology, and there is, once you get into humans, then everything breaks. But unit tests are tests that you write as programmer, just to kind of convince yourself that your code works. They are very useful, first of all, for not screwing up. They're also useful for documenting your decisions, right? That's where you test what happens with this exception, right? I'll make this break in this particular way and verify that it's returning the right exception. Verify that it's doing what it's supposed to do, right? On paper, I can write all my requirements, but paper will take whatever I write. This becomes code, and it becomes code that I can test. Does that idea make sense? That makes your life so much easier. Sorry?
There's one for that.
Yes. It's not perfect, right? How do you know that stuff works? You don't. You can mathematically prove it, that it works for certain things, very few. You can try them out and pray that it doesn't blow up, right? Testing gives you gives you levels of confidence, gives you levels of assurance, but have you tested every possible thing? Probably not, right? Because that's how it works, right? So let me close this project and go open one that has it, so we can show. Let me generate one that has it. Then I will show you kind of the magic behind the curtain. You remember, this is our beautiful, complicated assignment 0. Do you remember when you were young and innocent? Assignment 0. Woohoo! Look at this. This is unit test. I have included in the project the JUnit class, the JUnit jar. And so I'm including two things, assert and test. I'm importing assert and test. And so I do magic. I create a class. I annotate it with @test. I also annotated with this, but ignore this one for now. This is my own thing just for grading. That is not standard JUnit. That's for giving you the grades. I annotate it with add test, so it will get executed when I run Gradle W test or when I do testing in here. Okay, life is good. I like tabs. I can actually use JUnit as my never mind. I cannot, yeah. It is assignment. No. What's this? No. What happened? Never created it. How it should appear? No, I don't know how to use my IDE. If I do Gradle W test, I don't use an IDE. That's my problem. It will run all the tests, right? It will run this test, and it will run the tests in detail tests. And it will tell me there is bad stuff. Let me actually remove this class. Delete, refactor, delete. Cut, die, delete. So we only have one class that we're playing with. Just die. Beautiful. So now I will only have two problems when I do this. If you remember, we fixed it, right? So how do I write another test, right? How do I add more tests? As long as they are in the class, it's just a normal test, a normal method. Has to be public, has to be marked with as test. And then inside, I need to assert something. This is just a normal method, right? So what happens if, just get something that will crash. What happens if I add 2 max values? It's going to crash and it's going to tell me why it crashed. And I can go see, oops, why it crashed, and it will tell me what happened, right? So you could write more tests and figure out, well, what happens in this case if I have 2 really big ints and I add them up, what happens? They are at the edge of whatever I can represent in an int. Some bad stuff. In Java, what happens is I get a negative number. Isn't that cool? And that's depending on the representation, and so I may have wanted to do something else. But important thing, go for your own life, go figure out how to write JUnit tests or whatever. There's a bunch of other libraries. JUnit is kind of the most famous one. And then always do this when you're programming. I think the 2 most important things that I can get you infected in this class is Git. Hopefully after this class you put everything in Git, and you should never ever ever leave stuff outside of code review systems. And the second one that I hope that I will infect you is testing. Go test your stuff before. It's not magic. You still mess up. It's just usually you mess up less often.
And is that the structure that the unit test it should be in a separate folder?
It doesn't need to be, but it makes everybody's life easier. There is a lot of debate on these kinds of things. I tend to make most of my stuff public. Most of the time, my things don't need private stuff. I'm not writing libraries. And so it makes perfect sense to put them in completely separate folders, separate packages. They have nothing to do with each other. And the unit test is just testing the public methods, because everything's public. There may be other reasons to do it other ways. A good thing about putting it in a different folder and things like that, you normally don't want to deploy your test code. And so by keeping it separate, but there are books and careers made out of telling you how to test. It's a much bigger topic. In fact, if you are in the software engineering track, you take a class on testing. 1 full semester on different ways of testing stuff. So, but this is just kind of, I want to at least get you used to the idea and start as much as you can do unit tests. There is, even if you feel like it at some point in time, go read on TDD, which is test-driven development. Kind of the idea of you write your tests first before writing the code, and then you write the code to pass the test, and that sometimes leads to better code. I strongly recommend unit tests. I strongly recommend that you don't believe that this is instead of a tester. Having somebody to actually test your code, somebody else other than you, is great, because you get 2 people, and so if you miss a requirement, they'll catch it and that kind of stuff. Also because a good tester is evil, which is great. That's what you want. You don't want it's very hard to change hats and treat your code badly. It's your baby. You want it to succeed. The tester should be an SOB who wants your code to fail. And it's going to try to do everything it can to make it fail, which is what you want, because that means that when you demo it to your boss, it won't fail. But it's just a different mentality. I find it a lot easier to be evil with your code than with my code, right? When I grade, I'm not terribly devious or evil, but I can usually find errors because it's not my code. It's not my baby. Cool, and I think that's it for today. We'll play with some more examples of stuff on Wednesday. The last assignment is due on Monday. Isn't that cool? We are almost done. Cool and terrible, and the final exam is coming sometime soon. Are we gonna do it on the last day of classes, or are we gonna wait until?
When's the last day of class?
I think our time we were scheduled is the last day of finals. It's like December.
Oh, do they have it already scheduled?
They have it on the website.
Beautiful.
It tells you like.
Because it's, yeah.
I searched for it on Google.
Beautiful. Dates and deadlines, academic calendar. They have a final exam schedule. The last day of classes is December 5th. Which is a Monday. Yeah, we have Thanksgiving week, so we only have about 2 more weeks. For kind of covering, reviewing, and kind of covering other topics. By the way, if you are interested in any particular topics, let me know. My plan is the next week to cover kind of a smorgasbord of stuff. Maybe do some GUI stuff with Swing or something like that, or do some web apps or something like that. That will not be on the test. Hopefully, all of this stuff also helps you learn object-oriented programming and stuff.
The weekend after Thanksgiving will be revision.
Yes.
Okay.
And then we have the final on the 5th or on the 12th. 5th? Does anybody opposes the 5th? No? No complaints whatsoever?
Just tell me when to show up.
Cool. The 5th during class, sorry? Earlier. You just want to get it over with?
No, I have to travel again that week.
Oh, before the 5th?
Well, hopefully I'm not good. So we'll talk about it.
We can talk, yeah. Cool. Then I will see you guys on